This video is going to have a look at piecewise graphs and go through an example of how do we determine the equations from a piecewise graph. So a piecewise graph is a continuous graph formed by two or more linear equations that are joined at points of intersection. So in this example, we want to determine the equations from the piecewise graphs and their domains. So having a look at the graph that is provided to us, and we can see that there's going to be three sections. We have our first section, then we have our second section, which is a horizontal straight line, and then the third section, which finishes at 4 and 3. Now, the first thing I'm going to notice is on the first section, there's an arrow pointing beyond the graph, but on the third section, there's no arrow. So that means we have a definite endpoint, but no definite start point. So that is going to be important when we go ahead and have a look at our domains. But before we go ahead and look at the domains, we need to work out what the equations are going to be. So looking at the first line, and I can have a look and I can see that I've got a gradient of 1. So I've got a rise of 1 and a run of 1. So that means my gradient is going to be 1. So my equation 1 is going to be y equals x, and then my y-intercept is going to be -3. So it's going to be -3. So my first equation is y equals x minus 3. So to add in the domain, I can see that the blue line starts when x is equal to 0 and goes backwards. So my domain is going to be when x is smaller than 0. So that gives me the limitation of that equation y equals x minus 3. So having a look at the second equation, the one I've highlighted in green, and it's a horizontal line, so it is going to be y is equal to -3. Because it is a horizontal line, it has no gradient, so it is going to be y is equal to -3, and that occurs when x is between 0 and 2. So my domain is going to be x is in between 0 and 2. So then to finish off my equations, I need to have a look at the third line, which I've highlighted in yellow, and that is going to have a gradient of 3. So having a look, I can see I've got a rise of 3 and a run of 1. So rise over run, 3 over 1 is going to be 3. So it's going to have a gradient of 3x, and I still need to put in my y-intercept. I cannot tell the y-intercept from the graph we're given, so we're going to have to go ahead and calculate that. So off to the side, I know that y is going to equal to 3x plus c. I can take the set of coordinates that they've given me, 4 and 3, and substitute that into my equation instead of y and x. So 3 is equal to 3 times 4 plus c. So there I've gone ahead and I've added in my x and my y value. X is equal to 4, y is equal to 3. So I can go ahead and solve. So 3 is equal to 12 plus c. So when I move 12 over the other side, it will become a negative. So 3 minus 12 is going to be -9. So c is equal to -9. So my equation is going to be y equals 3x minus 9. So adding in my domain, it occurs between 2 and 4, and there's a definite endpoint. So my domain is going to be when x is in between 2 and 4. And because it has a definite endpoint, my final sign is going to be smaller than or greater than, indicating that is the definite endpoint. So using the piecewise graph, we've gone ahead and we have worked out what our three equations are going to be, and we've listed the domains. So that is an example of how do we determine the equations from the graph and also add in the domains for a piecewise graph.